Production mix and yield variances. In this video, we will evaluate production performance using production mix and yield variances. A production mix variance is a variance that arises from the change in relative proportion of inputs, materials, or labor. We'll be focusing on material yield and mix variances, but we could also look at labor yield and mix variances. A production yield variance is the difference between actual output from a given level of inputs and the expected level of output from those inputs. It's sort of a measure of our efficiency. Most products require more than one material, and some require a set amount of each type of material. For example, chairs require a set amount of metal, screws, foam, fabric, etc. Cars require 4 wheels and 1 engine. It can't be 3 wheels and 2 engines. However, we'll find that some products, the proportion of individual materials can vary. For example, in muesli, it requires oats, bran, fruit, and nuts, but the precise quantity of each is not critical. Oats cost less and take up more volume. Nuts, on the other hand, give us more weight for the same amount of volume, and a manufacturer might want to evaluate the relative portions of each of these we've used in a particular period in our production process. And this is true for many food production processes. We can use mix and yield variances to allow us to analyze the relative usage of the inputs, which would be the mix variance, and the resulting output of our product, which would be the yield variance. Let's go ahead and take a look at how we would break down a direct material variance. If you recall, up till now we've broken our direct material variance into 2 parts, a price variance and a quantity variance. Recall that the total material variance was the difference between our actual cost and our flexible budget, and the flexible budget is how much we should have spent given our actual level of production. We're going to go ahead now and take a look at how we can break down that quantity variance, and we'll break it down further into a mix variance and a yield variance. The mix variance will evaluate the relative proportions of the inputs in our process. In the case of muesli, what do we use? Nuts relative to bran, relative to fruit, relative to oats. And then the yield variance is our output relative to the amount of inputs we've put into our process. For instance, if we use more of the heavier weight nuts in our process, our final packaging will probably produce a lower volume relative to our expectations. However, if we use more of the lighter and less expensive oats and bran, our volume of output will be higher relative to the weight of the inputs that we've put into the process. The amount of waste can also impact our yields. Let's consider an example in which we are producing chocolate milk. Our chocolate milk is going to require 2 inputs, whole milk and cocoa powder. And to make a gallon of milk, we have the following standards. Each gallon of milk requires 3.96 kilograms of whole milk, which we expect to cost 60 cents per kilogram, as well as 4/100ths of a kilogram of cocoa powder, which sells for $5 a kilogram. So we can see to make our 4 kilogram gallon of milk, our standard mix is 99% whole milk and 1% cocoa powder. Let's go ahead now and walk through an example. In our example, we're going to produce 10,000 gallons of milk. And again, our standards for cocoa powder and milk are given. And we have a 99% to 1% relative ratio of the two. And we're given information regarding our actual cost of whole milk, cocoa powder during the period, and the total kilograms we've used. We're going to begin by looking at our direct material variance for whole milk, and we're going to pick up our actual amounts. So we actually used 4,200 kilograms at a price of 55 cents a kilogram for a total cost of $22,110. Our standard quantity allowed would have been 39,600 kilograms of whole milk, And we calculate that by taking our actual level of production, 10,000 gallons, multiplying it by 3.96 kilograms per gallon. And then, of course, we would multiply that by the standard price of 60 cents per kilogram to get a total expected cost of $23,760. Of course, the difference between the $23,760 that we would have expected to spend and the $22,110 we actually spent gives us a difference or a variance of $1,650. And this, of course, is a favorable variance because it's cost us less for whole milk than we would have expected. Let's go ahead and calculate our price and quantity variances. First thing we do is we pick up our actual quantity used and we multiply that, of course, by our standard price. And perhaps the first thing we observe is that we're going to have a favorable price variance. We expected milk to cost us 60 cents per kilogram, and it only cost us 55 cents per kilogram. Our quantity variance will be unfavorable because it took us 40,200 kilograms of whole milk to make our chocolate milk, and we would have expected it to only take 39,600. So we've had some waste in our production process. Let's go ahead and put some numbers on these. We calculate that center column. Our actual quantity times our standard price is $24,120. That gives us a price variance of $2,010. This is our 5 cents a gallon savings, a difference in price, times the 40,200 kilograms that we purchased. The quantity variance is 360, and that's the 600 difference in kilograms times 60 cents per kilogram. We're now going to break this quantity variance down into a mix and a yield variance. And recall, the mix variance will show us the relative proportion we used in terms of inputs, and the yield variance, the amount of output, in this case chocolate milk, relative to our two inputs, which were whole milk and cocoa. So again, we're going to want to break down our quantity variance into a mix and yield variance, and our color coding shows us how we're picking up the numbers. So again, we're going to break down this total variance, which was a $24,120 in our actual cost for whole milk, compared to the $23,760, which is what we should have spent to produce our chocolate milk using whole milk. And we're going to break that down into our mix and yield variance. We're going to begin by calculating what we refer to as the actual standard quantity, our ASQ. Given that we actually used 40,600 kilograms of raw materials, milk and cocoa, and 99% of that should have been whole milk, we would have expected, given that we used 40,600 kilograms of raw materials, that 99% of it, or $40,194 would have been, kilograms would have been the amount of whole milk that we used. And that would have been at a standard price of 60 cents a kilogram, and we have the expected cost of that, $24,116. Our mix variance then is $4, and it is favorable. And it's favorable because the 40,200 gallons that we actually used is less than it's unfavorable because we used more milk than we would have expected given the amount of inputs. Our yield variance is $356, and it is unfavorable as well. And again, it's unfavorable because we have used 40,600 kilograms of inputs to make 40 kilograms of outputs, our chocolate milk. And in particular, the 24,116 is greater than the 23,760. And of course, these two unfavorable mix and yield variances add together to give us our total unfavorable quantity variance. So from a mix perspective, we used more whole milk relative to cocoa than we would have expected, and our inputs didn't result in as much milk as we would have expected. And again, we can see that up here. To make 10,000 gallons, we would have expected to use 4 kilograms per gallon, 40,000 kilograms. We used 40,600, so we have an unfavorable yield variance. If we want to look at the relative proportions of whole milk to cocoa powder that we actually used, we can see that we used slightly more whole milk than would have been expected and slightly less cocoa powder. Of course, this contributed to or gave rise to our unfavorable mix variance for whole milk, and of course will give rise to a favorable mix variance as it relates to cocoa powder. Let's prepare our direct material quantity variances and price variances for cocoa powder. And again, we're going to pick up the actual cost for cocoa powder. And again, we actually purchased 400 kilograms at a price of $5.10 per kilogram for a total cost of $2,040. Let's go ahead now and look at our standard quantity allowed. In other words, our flexible budget. How much should we have spent in cocoa powder to make 10,000 gallons of milk? Our standard quantity would be 400 kilograms. And again, that's the 10,000 gallons at 0.4 of a kilogram per gallon. Our standard price is $5 per kilogram for a total expected cost of $2,000. We spent $2,040, so we have a total variance of $40, and it's unfavorable because the actual cost is greater than the standard allowed. Let's go ahead and compute our price and quantity variances. 400 actual kilograms of cocoa powder at $5 would have cost $2,000. Our price variance is 40, which again is simply that 10 cents a kilogram difference times 400 kilograms, and it is unfavorable because our actual price was higher than our standard price. We have nothing for a quantity variance because the actual quantity equaled the standard quantity allowed. And now we'll go ahead and break down this quantity variance and find out if it does have parts to it. And we're going to find that there is a mix variance. We expect one from our analysis above. And then we'll also consider our yield variance. So again, it's important to note, just because the overall quantity variance is 0 doesn't mean we can't have a positive mix and a negative or unfavorable yield variance. Again, we're going to take and analyze our total variance, total quantity variance, and we have our actual expenditures of 2,000. We had our standard allowed of 2,000. Let's begin by calculating our actual standard quantity allowed given our inputs, and that would have been 406 kilograms of cocoa powder. And again, remember, we had 40,600 total kilograms of inputs or raw materials. And if 1% of those is typically cocoa powder, given that we use that much, we would have expected to use 406 kilograms of cocoa powder at a standard price of $5 for a cost of $2,030. So we have a $30 mix variance. And again, that's the difference in quantity, 6 kilograms, multiplied by our $5 standard price. And that was a favorable mix variance. And we expected a favorable mix variance because we had an unfavorable mix variance for whole milk. Our yield variance is also $30, and that's the difference in quantity multiplied by our standard price, and it's unfavorable. And our total variance is 0. So to summarize our variances, we had a $4 unfavorable mix variance for whole milk. That was offset by our $4 favorable mix variance for cocoa powder. Our yield variance was $356 unfavorable for whole milk. Our yield variance was 0 for cocoa powder for a total yield variance of 356. And then our total variance for whole milk was 360 unfavorable a $4 favorable cocoa variance, giving us our overall total unfavorable materials variance of $356.